think, let me check how many classes we will need for covering this circle. After that, we can start statistics. And if not, today I'll see how many classes will be needed for circle. If not, then we'll be arranging extra classes for you. Okay?
Okay.
Yeah. So, yes, let's start circle. Four are there. No worries, let's start. So basically, circle, this chapter you have learned in the previous class also. Okay, these are the few theorems which you have learned in the previous class. We will be discussing about it. Just will be going through it, but not now. Okay, there are few terminology from circle which you know already. So if I am asking, what is the relation between diameter and radius of the circle? Can you tell me what is the relation between diameter and radius of
Diameter
any
is
circle?
radius will be half of the diameter.
Yes, radius will be half of the diameter. That's this one is very basic. Like before class 9, you have learned this concept, right, Galvin? Right, Fazan? Diameter is 2 times radius, or
Yes.
radius is half of the diameter. Now, if I am asking what is segment of a circle? What does that mean? Segment. Segment of a circle. Major segment, minor segment. Okay, before segment, tell me what is chord of a circle? Chord. Yes. What is chord of a circle? Chord. Yes, Maha, you are
Line,
saying.
a line that connects two sides of a circle, 2 points.
Yes. Line that connects any 2 point of a circle. That's called chord of a circle. Okay. Now, what is segment? Area bounded by chord, and this arc is called segment. This is called segment of a circle, and that's called, this one is the smaller one, that's called minor segment. And the bigger arc has whatever area it has just occupied with the same chord, that's called major segment. Do you know this?
Yes.
Okay, so this is called segment, like the area which we are having included by the chord and the arc. Okay, we call this we call as a arc. Okay, this one is the smaller arc, we are calling it, this one is giving us minor segment, and the bigger arc is giving us major segment. Now if I'll be asking what is sector, then sector of a circle, sector in a circle, area subtended by radii to radius, and again the arc. This is called sector of a circle. Okay, and this one will be called minor sector, and the bigger arc is giving us major sector. So in sector, we must get two radii and an arc. In the segment, we must get a chord and the arc. Okay, this one is called major sector. Okay, now there are few terminologies. See, I am starting the chapter. Last class I have announced also that today I'll be starting the chapter. Few students are not there. Once they will join, they will say that they are not getting what exactly I'm explaining over here. They are not getting anything. Of course, they will not get. If you are absent on any one of the day, if you are missing any class, whatever concept I'm discussing over here, of course I will be proceeding from there. Okay, so just keep in mind, if any time this is happening with you that you are not getting anything, think about it. Have you missed any class, or have you kept any doubt in your mind? Like a doubt was there, you was still not that clear, but you thought that okay, you will see at home, and the doubt will start getting building up. So please don't do. Okay. So yeah, we were discussing about the basic terminology which is related to circle. Now the terminology which we are going to discuss over here. Suppose we are having a circle and we are having a straight line. Okay, a circle and a straight line we are having. Now the chances are what will be the possibility if I will give you a circle and a straight line? What will be the possibility? The possibility will it be like this? Maybe the line will be just lie beside the circle, just like that. Or maybe or maybe the line will just intersect the circle like this. Or maybe the line will just touch the circle like this.
Called a tangent, right?
Yes.
When it
So
touches.
these are the only three possibilities we are having. If I'll be giving you a circle and a line, okay, maybe the line will be just as it is, and that's called non-intersecting line. Okay, because it is not touching the circle at all. Non-intersecting line. For this circle, this line is non-intersecting line. For the next one, since it is just cutting the circle, you can see, okay, in two parts, we will be calling it secant. So from now onward, whenever I'm saying secant, you must understand it is such a straight line which is just cutting the circle. And from the second only we will be getting the chord. Okay. So when we are talking about the chord, we are just talking about that line which is joining two point on the circle. Okay. But second is the extended form of that line. Am I making sense to all of you?
Yes, ma'am.
So second, first one is non-intersecting line, and the last one when a straight line is touching the circle at one and only one point. In this figure, maybe it's not that clear. I must draw it like this. Yeah, like this. That's the meaning of tangent. That it is touching the circle at only one point. Okay, it is touching the circle at one point, and that's called tangent. This line, if I am calling this as a line AB, this line AB is tangent to our circle. Okay. So when you will be having a circle and when you will be having a line, these are the only three possibility we can have. Okay. Now suppose we are having a circle. Suppose we are having a circle. Okay. And here you are having a wire. Okay, a wire you are having, and you are just tying the wire at a point P. You are having a circle, you are having a wire, you are just tying the wire at a point P. Okay. Now can we say at any point, like after a certain, like the wire will just move like this? Can we say if you are just tying at just at point P, can we say it will start moving like this, like this, like this? Can we say if we'll be having a circle, let's take a bangle. Okay, and if you will be just tying up a wire at a point P, so can we say the wire will move from here, the wire will move from here? Yes or no?
Yes.
It
Yeah.
will move, right? It will move. So if it will move, then we can understand that at a certain point it can look like this. It can look like this. Yes or no? See, I'm not doing anything. The wire itself, okay, we can just by itself it can move, or we can just we can just push it like this and it will start moving because we have tied the wire at one point only. Okay, so it will will touch the circle, maybe let's call at a point Q1. Are you agreeing that it can look like this when we are tying it at a point P?
Yes.
Yes.
Yes, Calvin, are you getting it? Fazan,
Yes, ma'am.
everyone
Yes.
getting it? That if you will tie it at one point only, there is a chance that it will move from here. So it can look like this. Okay, whatever I have drawn on the screen, it can look like this. Or maybe it can look like, it can also look like this. I wanted to draw all in a one row so that it will make sense to you. Let me draw it first. Can look like this Q1, or maybe can look like this. Or here only I can draw with different colors. Okay, or it can look like this at Q2, or it may look like this. Right? Yes or no?
Yes.
Yes.
So when we'll be moving, then it will just come closer and closer and closer to P. It is at Q1, then it can be at Q2. Then if you will, if we'll be moving the wire, still if you will be moving the wire, at last it can come at P. Now again, if still you are moving the wire, then it will look like this. Let me tell you, it will just go like this. Still if you are pushing the wire, it will look like this. Just a second. So, or maybe it will look like this, R1, and from this direction also. So basically I want to say the tangent, can you see, previously it was like a secant. Okay, PQ1 in this figure, can we say it's a secant? Can we say,
Yeah.
even if it will be at Q2, if it will be at Q2, this is P, and if you are very close to P, maybe here, okay, and Q2 you are calling it, still it's a second. Yes or no?
Yes.
Okay,
Yes.
write something on the screen. You tell me, are you getting it? The tangent is a special case of secant when two end point, end point means I mean the intersecting point. The tangent is a special case of secant when two end point will come closer and closer, and let me write directly. When two end point will coincide. That means when here you are having the end point as a PQ1. Here you are having end point as a PQ2. Still you will keep on moving. You will end up having again a tangent. Yes or no? Yes or
Yes.
no?
Yes.
That's why we are calling that tangent is the special case of secant. Okay, when this in end point will come closer and closer and closer and closer and will meet with each other, or will coincide. Coincide means just will lie on each other, and hence we will end up getting a tangent. Am I making sense to all of you?
Yes, ma'am.
Yes.
Pranab, you are getting, Maha, you are getting, Galvin and Fazan, are you getting it? That a tangent is just a
Yes, ma'am.
special case of
Yes.
secant. Okay, so it is a special case of secant.
Yes,
Previously,
ma'am.
it looks like a second. You will keep on moving, keep on moving, keep on moving, and you will feel that the end point which you were getting initially, it is coming closer and closer and closer and closer and just meeting with each other, and hence we ended up getting a tangent. And same thing will happen when your line will look like this, and when you will just when from here you will just take it like this, then again it will take a shape of tangent only. So it is just a special case of secant. Okay, now the next concept. And yeah, you understood what is tangent. It is touching the circle at only one point. That's called tangent. And the point at which the tangent is touching the circle, that point is called point of contact.
Ma'am,
Yes,
so like a circle can only have one tangent, or like how many tangents can a circle have?
a circle can have one tangent at one point. If I am telling you, Zainab, draw a tangent at a point M, then only one tangent you will be able to draw. But if I am saying that draw tangents, then so many infinite. At this point, if I am not mentioning, then how many tangent you can draw in this circle? Infinitely many tangents. You can draw a tangent. Just a second. You can draw a tangent from here. Wait. Just a second. You can draw a tangent from here, you can draw a tangent from here, you can draw a tangent from here, and not only from here, you can draw a tangent at each and every point. So how many points are there? Infinitely many points are there. That means in a circle we can draw infinitely many tangents. But if in the question a point is mentioned, that for a given point how many tangent is possible, then one and only one tangent is possible. Getting it?
Yes, ma'am.
Yes, everyone getting it, that how many
Yes,
tangents we
ma'am.
can draw in a circle. They're infinite, since circle is just made up of points. Circle is made up of arc. In that arc, so many points we are
Now, what
having.
if it passes through the radius?
Tangent passes through the radius.
Like, then there will be 3 points, right? If it passes like through the radius of the circle.
Are we talking about tangent passes through the radius?
No, in second.
Okay, secant passing through the radius. Okay, yeah, it can pass through the. This is also called secant. Okay, and this is giving us a diameter. Okay, the corresponding chord is called as corresponding chord of this secant is called as diameter. Okay, getting it? So basically what we are calling as a secant means a line, and chord means just the 2 point joining the circle. Okay, when you will be having a chord, you can extend it and you can call it, now it is secant. Okay, when you will be having a secant, you can just make the point of intersection like this, and you can say that this is the corresponding chord. Am I making sense? And what if it is passing through the radius? If it is passing through the radius like this, a secant is there, and if it is passing through the radius like this, then it is giving us a diameter. Can you see it? Getting it?
Yes.
Okay, so yeah, so yes, this point of contact, this point at which the tangent is touching the circle, that point is called point of contact. Is it clear so far? See what we have discussed. Let me summarize. We have discussed that when you will be having a circle, And when you will be having a line, the chances are the line is not intersecting the circle. That type of line is called non-intersecting line. When it is intersecting the circle, there is a specific name for that, and from now onward we will be calling it secant. So whenever you will hear this word secant, now from now onward, anywhere in the next class maybe, you will understand it is just a line, okay, intersecting the circle at 2 point. And from here, when we are having a line and a circle, we can have a tangent also. Now what else we discuss? Just a second. What else we discussed? We also discussed over here that when we'll be having a circle and if we will tie a wire like this, then we will realize that tangent is just a special case of secant. When the secant is just a line, okay, intersecting the circle at a 2 point. And if you will keep on reducing the distances, very small, very small, very small, very small, you will end up getting a tangent. So that's what I have written over here. This type of statement can come in the fill in the blanks. This type of statement can come in the true false question. This type of statement can come in the assertion and reason based question, that a tangent is a special case of secant when two endpoints coincide. When two end point of the second, the intersecting point of the second will coincide, will lie on each other, and we ended up getting a tangent. Is it clear so far?
Yes, ma'am.
Yeah.
Okay. Now the next part is, suppose we are having a circle. Okay. Now Maha said that what if the second is like this, passing through the center. So suppose if we are having a second like this, passing through the center. Okay. Now let's draw, suppose this one is AB. Let's draw a few lines parallel to this AB. We want to draw lines parallel to AB. Okay. We want to draw lines parallel to AB. Let's draw it. So we can draw a line like this, which is parallel to AB. Towards the right side also we can draw, towards the left side also we can draw. We will be drawing it, okay, by ourselves. So let's keep on drawing lines which will be parallel to the second. Okay, similarly we are going to draw lines on the right side of AB also. You can see which one is AB. This middle one is AB. Okay, so towards the left, I mean left side of AB also, let's draw a line parallel to AB. Actually, it will look like a diagram. What exactly we are doing over here? We are doing one activity from where can we see that for a given second, for a given second AB, there will be maximum two tangents we can draw, which will be parallel to AB. Yes or no? And can you see maximum two tangent only we can draw, which will be parallel to the given second. Getting it? If you will be having a second, not necessary passing through the center. However, in this question, I have taken passing through the center. But if you are having any second, can we say that maximum two tangent we can draw, which will be parallel to the given second? Can we say that?
Yes.
Yes. Okay. So it is not possible to draw more than two tangents, okay, which will also be parallel to the given second. Okay, if you are having any second like this, you can only draw maximum two tangent. You can understand one on the top, another on the, like, one over here you can draw and one over here, and that is these two green lines are parallel also, and it is tangent also. So maximum two tangent you can draw only for a given segment second. Getting it, Galvin, Fazan, are you getting it? If we are having a second and if we want to check how many tangents can be drawn, which will be parallel also for to the given second, then we can only draw two, maximum two. Getting it, Galvin and Fazan, are you getting it?
Yes, ma'am.
Getting it. So for a given second there will be maximum two tangent which will be parallel, okay, which will be parallel to AB. Logically it is also true. Think about it. One on the top you can draw, one on the bottom. Parallel line can't be like slanted, can't be inclined, it has to be parallel. So of course only two we can draw. Okay, let's move. Now few activity based like concept we are discussing with the help of the activity. Okay, I'll be summarizing everything at last. Just focus over here. Now the next activity. Again, I'm summarizing what we discussed so far so that you will not mix everything, because in all the activity we are taking a circle, a wire, a second, whatever tangent. So first we have taken a circle and a line and we realize that what is the name. Okay, when the line is not intersecting the circle, we'll be calling it non-intersecting line. When it is intersecting it, we'll be calling it secant. When it is touching the circle at one and only one point, we will be calling it tangent. Tangent at P, and this point P is called point of contact, which we will be using when we are talking about tangent line. Okay. Now after that we discuss that the tangent is the special case of secant, when two end point or two the intersecting point will coincide and we will end up getting a tangent. After that, we discuss that if we are having a given secant, anyway, here I have taken in the middle, but think about it. If you are having a given secant, then only two tangent you can draw, which will be parallel to the given secant. Is it clear so far?
Yes.
Yes.
Now in real life also, you must have seen, or you must have seen in the picture, that for taking the water from the well, people use pulley which looks like this. Here you can just use the bucket, and you must have seen in the pictures in your book or somewhere, or maybe you can have like in movies also you must have seen, or maybe in reality maybe. Okay, so have you seen this type of pulley, which like which can be used for pulling the water? Does it looks like a tangent line? This line is also a tangent, and this line is also a tangent. Does it looks like that?
Yes.
Yes.
Okay, so yeah, these are the tangents, okay, which we can see in our real life also. Apart from that, when when a bicycle wheel, suppose we are having a wheel, okay, I'm drawing a wheel over here, and here the spokes are there, okay, like this. Can I say these all the spokes are nothing but just the radius? Can I say? Can I say these all are just
Yeah.
radiuses? Yes.
Yes.
Hassan, Galvin, can we say that this all the spokes of this wheel? I am trying to draw a wheel, okay? And these are just the spokes you must have seen, okay, in bicycle wheel. So these are nothing but just the radius. These all are the radius, okay? Now, when the bicycle is just, suppose this is the ground. So when it will just the wheel will move on the ground. Can we say it just looks like a tangent? Can we see, can we say it
Yes.
looks like a tangent? Okay, it is nothing but the ground is working like a line, okay, which is tangent to the circle. And if we will observe carefully, this radius looks like perpendicular to this tangent. Yes or no? We are just telling it by observation. Does it looks like
Yes.
perpendicular to this tangent? Yes, it will be perpendicular. The radius through the radius joining, like the radius through the point of contact will always be perpendicular. Okay, perpendicular to the tangent. Radius which we are having, any radius? No, which is passing through the point of contact. This point is called point of contact. If we are talking about, if we are saying this is a tangent line, if we are saying this is a tangent line, then point P is called point of contact. So can we say the radius passing through the point of contact is perpendicular to the tangent? Yes, we can say that. Here we are saying it by observation, but now only I'll be showing you with the help of the proof also. Okay, my laptop is running out of battery, so let me open it. Yeah. So there is a theorem also which I am going to write on the screen. It says that the tangent at any point of the circle is perpendicular to the radius to the point of contact. Okay, this is just what I just said just now. This is just completely observation based. That you will find that. Okay, whatever the spoke which will come vertically, okay, at just touching the ground level straight, you will realize that it looks like perpendicular. However, we are not sure. Okay, sometimes the line looks like perpendicular, it may or it may not be perpendicular. For that we are having a theorem that the tangent at any point of the circle, what the theorem says, the theorem says that the tangent at any point of the circle, if we are having a circle, okay, the tangent at any point, suppose here I am drawing the tangent, okay, so tangent looks like this. The tangent at any point of the circle, maybe this is point A, okay, the tangent at any point of the circle is perpendicular to the radius. It's perpendicular to the radius through the point of contact. Okay, if you are drawing the radius over here, here it is perpendicular. That's what the theorem says. It is perpendicular to the radius. Now in this circle, how many radiuses are there? Infinitely many radius we can draw, but it is perpendicular to that particular radius which is passing through the point of contact A. Okay, so this radius we are talking about, it will always be perpendicular. Now think about it. Think about it. If we are having a point, okay, and if we are having a straight line, okay, if I'll be telling you, find the distance of this point from this line, find the distance of a point M from the line AB. Can we find distance like this? Yes, we can find. Yes or no?
Yes.
Yes or no?
Yes.
If I'm telling you instruction, listen to me. If I'm telling you, you are having a point M and you are having a straight line A, find the distance of M from A. So you can find this distance, or maybe you can find this distance, or maybe you can find this distance, or maybe you can find this distance. Like this, you can find any distance. Okay, so everyone's answer will be different. Okay, like one of the students said the distance is 15 centimeter, another student said no, the distance is 12 centimeter, another student came and said no, I'm getting 10 centimeter. So which distance will be taking? We will be taking the shortest distance. Shortest distance means this perpendicular distance will be the shortest. Think about it. Is it visible to you that this perpendicular is the shortest distance? Can you see it?
Yes.
It will be the shortest distance. So whenever in mathematics we are talking about a distance of a point from a line, always we'll be talking about the shortest distance, that means the perpendicular distance. Okay, distance, think about it. In coordinate geometry chapter you must have heard that this coordinate over here is maybe 3 comma 2. So we used to drop the perpendicular to check the distance. Yes or no? Yes or no?
Yes.
Okay,
Yes.
so whenever from now onward, whenever we are talking about distance, we are always talking about the perpendicular distance. Why perpendicular distance? Because that is the shortest distance. Okay, so if we are, let's get back to our theorem. So the tangent at any point of the circle is perpendicular to the radius through the point of contact. Okay, we are trying to say that this OA, this OA, we are trying to prove that this OA is perpendicular to this PQ. Okay, we don't know, whether it is perpendicular or not. We are having a circle, we are having a line, a tangent line. We are just having a circle and a tangent. And what we are trying to prove? We are trying to prove that if we will join the radius with the point of contact, we will end up getting 90-degree over here. That's what we want to prove over here. Okay. Now think about it. If you will be taking any point, any random point, see, this theorem doesn't come in exam. Okay, you will be using this theorem. Proof, you don't have to prove anywhere. Okay, but still, this is just a statement based and observation based. I'm showing it to you. So what we'll be thinking, that if we will be joining this O with Q, let's join the O with Q. Can we say OQ is of course bigger than OA? Can we say?
Yeah.
OQ OA से बड़ा है क्योंकि Q पॉइंट सर्कल के बाहर लाई कर रहा है. अगर हम सेंटर को सर्कल के बाहर लाई करने वाले किसी पॉइंट से ज्वाइन कर देंगे तो ऑफ कोर्स वो रेडियस से बड़ा हो जाएगा. हाँ या ना?
Yes.
गेटिंग इट? अगर हमारे पास एक सर्कल है और अगर हम सेंटर को किसी बाहर वाले पॉइंट से ज्वाइन कर देंगे, सपोज हियर इज द पॉइंट, ऑफ कोर्स ये जो हमें डिस्टेंस मिल रहा है, ये जो लेंथ होगा इस लाइन का, ये हमारे रेडियस से तो बड़ा होगा. राइट?
Yeah.
राइट? ओके, even if we are taking very closer a point and if you will join it with center, okay, still it will be bigger than radius. Yes or no? It will be. Okay, Galvin, Fazan, are you getting it? ओके, सो ये Q जो पॉइंट है हमारे पास, ये कहाँ लाई कर रहा है? सर्कल से बाहर. अगर हमने सेंटर से ज्वाइन किया तो ऑफ कोर्स OQ विल बी बिगर देन OA क्योंकि OA तो हमारा रेडियस है. गेटिंग इट? सिमिलरली और एक पॉइंट ले लेते हैं, चलो चेक कर लेते हैं. और एक पॉइंट ले लेते हैं, P. OP को ज्वाइन करते हैं. OP विल बी ऑल्सो बिगर देन OA. अच्छा ठीक है, downward, let's take a point in this side, maybe a point over here or maybe very closer to this one, and let's join this. Still it is bigger than OA. तो क्या हम ये बोलना चाहते हैं कि OA शॉर्टेस्ट डिस्टेंस है? यस, हमें यहाँ से ये पता चल रहा है कि OA शॉर्टेस्ट डिस्टेंस है, और क्योंकि ये शॉर्टेस्ट डिस्टेंस है, ये परपेंडिकुलर डिस्टेंस ही होगा. गेटिंग इट?
Yes.
Yes.
Everyone getting it? See, the proof doesn't come because all I can write over here is the statement that since OQ is bigger than OA and OP is also bigger than OA, that represents that OA is the shortest distance. Hence, that OA is the shortest distance. Joining O and a point on the line. Hence, OA must be perpendicular to this line PQ. Is it crystal clear to all of you?
Yes.
Okay, I'm going to summarize everything. We have discussed so many things today. Okay, and whoever have missed the class, really they have missed like this all the things. Now we will, from the next class we'll be doing fill in the blanks, we'll be doing questions, we'll be discussing more theorem, but these basics I won't be able to repeat. So yeah, let's continue. So we started today's discussion with a circle and a line. Line can be non-intersecting line. It can be intersecting. Intersecting means second line. And if it is touching the circle at only one point, just a point, that means we are going to call it a tangent line. Tangent line, the point at which it is touching the circle, that's called point of contact. After that, we realize that tangent is just the special case of secant. When you will be having a secant, you will just move it, and at the end you will find that you will end up having a tangent. So with the help of secant, you ended up getting a tangent. So tangent is a special case of secant where both the intersecting point or the end point just came closer and coincide with each other. Okay, now the next one, if you are having a secant, anyway, a secant or maybe a secant, anyway you are having a secant, then you can draw only two lines which will be parallel to secant and will be tangent to the given circle. only two tangent you can draw which will be parallel to the given segment. Okay, if you are having a circle and randomly I'll be giving you a secant, then you can only draw two tangents from here and from here, which will be parallel to this secant. Okay, maximum two tangent. Next one, when we are just observing the bicycle and the spokes, we realize that always when the wheel is moving, okay, at the point of contact the radius is perpendicular, but that is just the observation. Okay, always at the point of contact, at a certain point of time the wheel will be here. Okay, maybe here point of contact the radius, like another radius will come over here, maybe this one, let me draw it with a specific color. Maybe this radius just came over here, now it will be perpendicular, okay, to this tangent at point of contact. That we proved with the help of this theorem. The theorem says that the tangent at any point of the circle is perpendicular to the radius through the point of contact. So if you will be drawing a radius through this point of contact, that radius must be perpendicular to this tangent. Okay, so that's what we realize when we were joining with different point. We realize all the distances are more than this OA. That means OA must be the shortest distance. And shortest distance in mathematics is called the perpendicular line. Okay, which we discussed with the help of this example. Is it crystal clear so far?
Yes.
Okay, so today we'll be keeping this much. No assessment since we just started with the concept. Okay, and in the next class we'll be discussing few more theorem and then we'll be solving the questions. Yes, Maha, your exam, and today in the next class I'm informing you whether we are going to arrange a class for you or here only it will be possible. Okay.
Okay.